Okay, so here's another question we're going to integrate using substitution. So right off the bat, when you look at that integrand, it's quite, it's quite complex. To tell you the truth, I don't really want to expand this 4 times. I don't really have the time for that. So let's use substitution. So first of all, how do we know we have to use substitution? So I usually look at the fact that we have a composite function, and inside that composite function, when I take the derivative, which is 2x, I actually get the outside function. So it does take quite a bit of, you have to recognize it first. You definitely have to analyze it and figure out whether or not it does follow that pattern. Now, if it does, I'm actually going to take my u, which I just use for substitution. Honestly, you can use any variable you want, but I'm just going to use u, and I'm going to make that equal to the inside function, which is x squared plus 7. So make u be equal to the inside function. Then I'm going to rewrite it like this. I get 2x, and then I get u to the power of 4 dx. So right now, it's not ready to be integrated because, well, first of all, I have an x still there, and then I still have dx, so I can't integrate yet. So I need to rewrite 2x and dx in terms of u instead. So here, to get that to happen, I need to take u is equal to x squared plus 7 and integrate both sides with respect to x. Okay, so when I get that, derivative of u with respect to x is du dx, and what we get here is x squared. When we take the derivative, we get 2x, and then derivative of 7 just gives you simply 7. So once again, I'm trying to rewrite 2x dx, right, in terms of u instead. So if you want, I'm going to actually rearrange this. This is u to the power of 4. Okay, I'm going to bring the 2x and the dx together as 1. Now, the reason why I'm doing that is because I actually can get this expression from this equation. And the way I'm going to do that is take dx and bring it to the other side, and I get du is equal to 2x times dx. And look at that. 2x dx is really equal to du. So I'm going to replace or substitute that in. 2x dx is du. And now I can integrate this because everything's in terms of u, and everybody should know how to integrate u to the power of 4. That's just going to be u to the power of 5 over 5 plus c. Now, I wouldn't state that as the final answer, though. I have to replace u with whatever I made it equal to in the beginning. And u was x squared plus 7. So I'm going to go x squared plus 7 to the power of 5 over 5 is going to give me, plus c is going to give me my integral of that function. Okay, so that's pretty much how you do that question. Let's try another one just like it. This one here, okay? Okay, so first of all, don't let the square roots scare you. Okay, that is really just x cubed minus 4 to the power of 1/2 dx. Okay, so this is still a composite function. This is a composite function right here. And outside of it, we get x squared. Now, if I take the derivative of the inside function, x cubed minus 4, I get 3x squared. It doesn't matter about the 3. I'm only concerned about the degrees. They're the same when I take the derivative. So I can use substitution here. Okay, so what am I going to use for substitution then? U is going to be equal to the inside of the composite function, which is x cubed minus 4. Okay, so I'm going to rewrite this. I'm going to go square the integral of x squared. I'm going to write x cubed minus 4 as u instead. So I have u to the power of 1/2 dx. So I need to somehow replace x squared and dx with something in terms of u instead, because I can't integrate this as is. So at this in this equation here, I'm going to integrate both sides with respect to x. Okay, and I get du dx is equal to 3x squared, and then the derivative of negative 4 is going to be 0. Okay, this is all I have here. However, what I want is x squared times dx. That's what I want here. So I can get that here by taking dx and bringing it to the other side. I get du is equal to 3x squared times dx. Now the problem is I wanted x squared dx. That's what I want to replace. So I have to bring the 3 over to the other side by dividing it. So therefore, du over 3 gives me x squared dx. So going back into here, I'm going to make that substitution. I have u to the power of 1/2 x squared times dx. Well, I have an expression for that. That's really du over 3. Now from here, I'm just actually going to take this division by 3 and just bring it over here instead. So this will look like this: u to the power of 1/2 over 3 du. So from here, I can go ahead and take the derivative because everything's rewritten in terms of u instead. So when I take the derivative, or antiderivative, sorry, I'm going to go u to the power of 1/2 plus 1, which gives me 3 over 2, and then we're going to divide by 3 over 2 as well. So I had a 3 there originally, and now I'm going to divide that by 3 over 2. Okay, and add c at the end there. Okay, so to simplify all of this, I get u to the power of 3 over 2, and then 3 times 3 over 2 is going to give me 9 over 2. So just as a simplification, dividing by 9 over 2 is the same thing as multiplying by its reciprocals. So I'm going to end up getting 2 over 9 in the front there, plus c. And then finally, the last step is to substitute whatever u was in the beginning. Now u was, I believe, x cubed minus 4. So I'm going to make that substitution. X cubed minus 4. And that's to the power of 3 over 2 plus c. So that's how you do that question.